Hello guys, once again, so this is the last video under this chapter. It's the last video under this chapter. So I'm just gonna jump straight in. There's a quadratic number patterns. The first question, it says show that pattern above this number pattern is a quadratic. A thing for you to sort of know is, for a quadratic, you have the first difference and the second difference. Sorry for that. And the first difference, it's gonna be a linear number pattern. The second difference, it's gonna be I can say a constant number, but it's gonna be a common difference, right? Because from a linear number pattern, we get a common difference. So we can do just that. 24, 10, 0, minus 6, and it continues. All right, we can do our first difference. Minus 6 minus 0, that's minus 6. 0 minus 10, minus 10. 10 minus 24, minus 14. Right, we can do our second difference. Minus 6 minus 10, that's 4. Minus 10 minus 14, that is 4. Right, so remember, there's the second difference right here, second difference, and right here you have your first difference. Right, so I'm just gonna say, you can see that your second difference is a common difference, and that common difference is coming from the first difference, which is a linear number pattern. Right, so and then you're done. And the next one, it just says as finding a general term. Since we've already done the differences, so 4.2, so it's time. Schools are coming out now, so you might, hopefully the noise from young kids going home back from school and make much noise on the video. So let us continue. We have 2a. What is 2a equals to? Just think, and it has to be equals to 4, implying that a equals what? Equals 2, right? Next question. No. We have also 3a plus b equals to what? Equals to minus 14. Damn, minus 14. Then that means you have 3. Or I can just say, yeah, let me just put it there. Plus b equals minus 14, implying b equals minus 14, minus 6, that is minus 20. You're gonna have a plus b plus c equals what? Equals 24. You do the math. 2 minus 20 plus c. You have c minus 18 equals 24. C equals 24 plus 18, and that should give you 42, meaning that therefore tn equals to 2n squared minus 20 and plus 42. Right, from that you are done. And we go, they say calculate what? Calculate t40. I will check again, just forgot. They say t something 52, t52. Right, we're gonna take the formula and say t52 equals to, and where we see n, we substitute 52, we are minus 20, 52, 42. Right, so we have what? This is gonna be 2 times 52 squared minus 20 times 52 plus 42, which is 10, right? Straight from the calculator. Determine the smallest value of the quadratic. Okay. Yeah, this is the question that actually made me pick this, question number 4, right? I saw this question, I was like, quite interesting. So determine the smallest value in this quadratic pattern, eh? So we have that formula right there, eh? And looking at the formula, we can tell that, remember, quadratic there's a quadratic pattern, ne? So remember, back in grade 10 we dealt with quadratic functions, ne? And looking at this quadratic function we have here, a quadratic equation here, a is positive, ne? A is greater than 0, and therefore you're gonna have this shape, in your Cartesian plane. No matter, it doesn't matter whether how, but the shape, we care about the shape. The shape is gonna be like this, and you're gonna have a value here, a value of y, which will be the smallest value of y, because then for all these other values, this will be, the values are gonna just keep on increasing to infinity. So in this problem, if I give the range, the range of this thing is gonna be, maybe I'll say y to let me include y, it's included, y to positive infinity, right? And the value we are trying to find is this one, right? Is this y, ne? The question is 3 marks, so it shouldn't be a problem, right? But now the thing is, what do you remember? That value we are looking for, it's the turning point, ne? It is the turning point of your parabola. So which formula are we going to use, ne? Which formula are we going to use? I would let you maybe give you some seconds to think. Yeah, well, I'll give you some seconds to think about it. Once you know the formula, you can just substitute and get the answers, right? So that formula we're looking for, it's okay. You have y equals to what? Y equals to you have minus, it's b squared minus 4ac, and then you have 4a, and this is the formula we use to get what? To get the y value of the parabola, right? In this case, so let us just do that. Your b here is minus 20, so you have minus 20 squared, there's a negative, then you have minus minus 4a, which is what? Which is 2, c, which is what? Which is 42, right? Divided by 2, 4 into what? Into a, which is 2, right? You put that in a calculator, you have, I'll just say 20 squared. It doesn't make a difference. 4 times 2 times 42, 4 times 2, we're getting minus 8. And by this, it's just sadly telling you that minus 8 will be the lowest value of of our quadratic function. Yeah, so if you have never seen this video, this formula, don't worry, you will see it. But yeah, so you basically just find the turning point of of this parabola, which that turning point, like I said, that will be your you'll find your what, your lowest y value, because then from that point going upwards your y values just keeps on increasing. Let's see. Determine value or values of n for which the terms of a quadratic pattern will be positive. So I need some space, so I'm gonna, maybe I'm just, let me remove this one, delete. So we trying to solve, we are solving for this now, ne? We are solving for this, right? Yep. Yeah, we are solving for this inequality. We can just divide by 2 both sides, which is everywhere we end up with plus 21, right? And here we just factorize this. Yeah, so we just have to find 2 numbers that when you multiply them you're gonna get 21, and if you add or subtract you're gonna get 10, right? So let's find factors of 21. 1 and 21, 2, 3, 3 and how much, and 7, 7, 14, 21, and that's exactly those 2 numbers. Both of them needs to be positive, right? But now remember, when you're solving inequalities, when we get to this point we treat this thing as an equal sign, right? So you realize that we're gonna have n being what, n being 3 or n being 7, of which at the time we draw our number line, right? Our number line, we know we have 3, we have right here we have 7, and if we do the math you would see that, let me go back to my calculator, say, and say take any number, maybe 0 that is below 3. I'm thinking 0 minus 3, this side I have 0 minus 7, so I'm getting a positive value, so this side it's positive. And if I take any number greater than 7, I'm thinking 10, let's see, I'm getting a positive. Any number between these two, I'm thinking 5, I'm thinking 5, I'm getting a negative, right? So we are solving for this thing, we're looking for where we're gonna get positive values, right? This whole thing, it has to be greater than 0, and it's clear it's from here, right? Maybe let me here going that way, and it's gonna be here going that way. Yeah, my arrow here is just bad. So the reason I'm also like not making the circles to be clear and not shaded is because at 3 and 7 they are not included. If it happens that our n is equals to 3, like in this case we saw we got 0, if our n equals to 3, what's gonna happen? We are going to get a number that is 0, and if we substitute n being 7, we're gonna get a number that is what, that is 0. So what does that mean? I'll remove this part. Oh no. So therefore you have the answer is gonna be a union of, we can say n is an element of these, from negative infinity to 3, right, union 7 to positive infinity, and that's it, you're done. And of course, just to add a little bit, you already see that here, if you were to draw this one, you'd have in fact, yeah, I need to move this one here. Cool. So what damn. Alright, cool. So this is your y-axis, this is your x-axis. So you already know that you're gonna have something like this. And somewhere here you have -8, and that's where your turning point will be. There is 3 here, so your thing, it goes like this, right? And then here it will be like 42, but it has to be more curvy like this, man. Hey, I'm making it more like a V now. This is 7, this is 3, it's gonna be something like this. Yeah, it looks more like a V, but of course it should be curved. I can just say not drawn up to scale, but yeah, that was this problem. Let's see what we have next. um cool. Here they're saying it's a quadratic pattern, it has a general formula. There we go. And yeah, I'm gonna do this just to solve this one. They say we have to determine what a and b is. We have term 1, we have term 2, we have term 3, we have term 4, right? And then term 2 minus term 1, they say it's 3, and term 3 minus term, this is 7. This is 7. So here's what I'm gonna say, guys. Like, it looks like a really challenging problem, this one, but I promise you it's not, because with your knowledge they already told us this is a quadratic number pattern. So you know that the second difference is gonna, it has to be a positive, it has to be like a common difference, right? It has to be constant throughout. 7 minus 3, that's 4, right? From here you can then say 2a equals to what? Equals to 4. A equals to 2. You're done, right? Then you go to 3a equals to no, 3a plus b equals to 3, right? Then that's 3 and that's 2, right? You have b equals to 3 minus 6 minus 3. Then you are done, right? Then you are done. If they did ask you to find, let me just add this question and maybe create something from it. Let me see if I actually can. So of course from this I already have a c here. That means I can just say with a different color, therefore Tn equals to 2n squared minus 3n minus 15, of which I can use that and find my Tn's. I can find T1 to be 2 1 squared minus 3 1 minus 15. I can have 2 squared minus 3 2 minus 15 2 3. This would be a 3 minus 15, and I have term 1, term 2, term 3. This is term 2, this is term 3, and so on and so on and so on. Yeah, I didn't look at this question, I just took it. I thought it was gonna be something heavy, but yeah, some light. Maybe here we have something heavy, because it's actually 6 marks. So let's see. They say term 1 is p, so I'll say p. Term 2 is 18. Term 3 is term 3, and then term 4 is 4p, right? Okay, I'm just saying 4p because they're saying term 4 is 4t1, right? So yeah, we substitute, we have 4p, right? And it's a certain quadratic pattern, right? So we know a thing or two about this. If we were to find the first difference, so 18, you have 18 minus p here. So term 3 minus term 2, they did say it's 10. Sorry for that. And then yeah, here we're just gonna get like 4p minus t3, whatever t3 can be. All right. So here our objective is to find what? Our objective is to find p, né? Maybe let me go down to see what I'll get. If I say 10 minus 18 minus p, I end up with 10, and then that's minus 18 plus p. That means I have p minus 8, né? And that's gonna be my what? That's gonna be my first difference. My second difference. I'm sorry for that. Yeah. Right. Cool. Yeah. Very cool. Very cool. And just to show you something, if so this is part of the solution as well. These guys, they say T3 minus T2 equals what? Equals 10. T3 is gonna be what? T2 plus 10, which is 18 plus 10, which is 28, right? So yeah, let me rewrite this whole thing down. I have P, I have 18, I have 28, I have 4P, right? Here I have 18 minus P, I have 10, I have 4P minus 28, né? And then I'm gonna have P minus 8, né? Yeah. Here I'm gonna have, let me work it out here, 4P minus 28 minus 10, that's gonna be 4P minus 38. So here I'm gonna have 4P minus 38, right? And remember, né, this right here, that's my second difference. And then here, that's my first difference, right? So one thing I know for my second difference, P minus 8, né, it has to be equals to 4P minus 38. So now I'm transposing, that's gonna be minus P, and I have what? I have 38 minus 8, and that is 3P, and I have 30, and divide by 3 everywhere, you get 10. So P is equals to 10, right? Which is exactly what we was trying to find. And yeah, we are done. It seems like this one was also no-brainer. It was just a lot of work. Yeah, just a lot of work. Let's see this one. I think this is the second last one. This one is also quite interesting. We're dealing with the quadratic number patterns. Hey, these kids are making noise. But yeah, we have, they say calculate the value of x, né? Calculate the value of x. Yeah, this one was also quite interesting. I was like, just try to do it. So 4.1, I have x plus 8. So yeah, I can find my first difference, which is x plus 1, 3 minus x, and it's gonna be x plus, then I have 8 minus 3, that's 5. So I'm gonna have something like this. This is my first difference. Now I can find my second difference, is the one that I think is gonna help me a lot, né? Because here I'll be having two second difference. I can equate them to each other and find x. So yeah, okay, cool. So I can say, you guys know that this, right, is a linear pattern, linear, number pattern, né? So because of that, I'll just say this is term 1, term 2, and term 3. All right. Then from that, I can also add and say from this I'll just say t2 minus t1, it must be equals to t3 minus t2, right? And I do just that. I have x minus 3, no, 3 minus x minus x minus 1, x plus 5 minus 3 plus x, right? And now I'm just doing the maths. On this side I have 2x minus 2, on that side I have 2 minus 2x, right? And that 2 goes to that side, so I have 2 plus 2, I have 2x plus 2x, 4x, 4, 1 equals to x, ne? So yeah, I found my okay, I found x which is equals to 1. Yeah, and then they say show that the nth term can be rewritten like that. Oh, written like that, not rewritten. Shit. Alright, cool. So now I'm just gonna maybe put it properly. I have minus 1. I have, you know what, since the values that I need to work out my formula are these values right here, ne? These are the values. Even though I didn't write this one, I'll write it. So I'm just gonna focus on them and not do what I was gonna do, ne? So for the where I have t1, look, the numbers is I have minus 1, and then I have, it's, you see here, x plus 1, 1 plus 1, which is 2, so I have 2, right? And yeah, and then I have to find out this one, t2 minus t1 is, here is t2 minus t1. Let me use a different color. Here is t2 minus t1, right? This right here, this is t2 minus t1. If I substitute 1 there, what do I have? I have 0. Yeah, which is quite interesting. Yeah, okay, I don't believe this, but this has to be 0. You know what, let me go back to my, the method I was gonna do. And yeah, but before maybe I might have done a mistake, so let's go back. Yeah, let's go back. So I want to focus. I know everything that I did is kind of like nah. Yeah, one erase the entire stroke. Yeah, so right here I'm just gonna confirm if vele everything I wrote is actually nah. Yeah, well, quite proper, so I have 3x minus, so yeah, that's minus shit, and then that's gonna be 2, that's gonna be minus 2, and yeah, and then cool. So I check the site. I just saw a mistake. So right here, 5 minus 3, I wrote minus 2 there, which should be just this, right? And if that is the case, of course, now I'm gonna have minus 2, and I'm gonna have 0, and therefore I'm gonna have 0. So what does that mean? It means x is gonna be 0, right? Yeah, it means x is gonna be 0. So in that case, I have a pattern like this: minus 1, 0, 3, and I have 8, which remember now I'm trying to write, right? Yeah, so 0 minus 1, that's 1. 3 minus 0, that's 3, and then 8 minus that's I think 5. Yes, that is 5. I do the second difference, it's gonna be 2. So now I know what? I know that 2a equals to 2, that means a equals to 1. 3a plus b equals to 1, that means 3b equals 1. B equals what? B equals 1 minus 3, which is minus 2. And then I have a plus b plus c equals minus 1. And that is 1 minus 2 plus c equals minus 1. So you have, okay, I can just say here you have minus 1 plus c minus 1, then c 1 minus 1, c equals to 0. So it looks like I've run out of space. So it looks like your function is, it's gonna be n squared minus 2n and plus 0, right? I can just leave it like this, né? So now I go back and I try to see. So okay, cool. I'm gonna create more space for myself. Yeah, I need more space here. I need more space. So I found my Tn to be n squared minus 2n. So now we're going to complete squares. If you don't recognize, they are just asking us to complete squares here. And that's how we're gonna write this Tn into this thing that they have here, right? Remember, completing squares, you have, first thing is to make sure that the coefficient of n squared is 1, which is the case here. So then we go to the second term. That second term, we're going to divide it by 2, right? If we divide it by 2, we look at the coefficient, which is minus 2, we divide it by 2, we get what? And let's forget about the sign, we get 1. So that 1, you're gonna square it, and then you're gonna add it and subtract. So I've squared it, so I'm gonna add it, 1 squared, then subtract it, 1 squared, né? And now what do I have here? I have something like this, of course, the square. I group the first 3, let me use the same color. I group the first 3 terms, and I know those terms are just gonna be n. Since the middle term is a minus, then I'll have a minus 1. This one is coming from inside the bracket, squared, and then minus 1. Voila! Which is exactly what they asked you to do. Interesting question is be like 4.4, so I'm just gonna move this for more space. Cool. So 4.3, that is, they say what value. Okay. We're basically calculating T65, which is just here where we see n, that's 65 minus 1 squared minus 1. Put that in a calculator. 65 minus 1 squared minus 1, that's 4095. And the last problem, I think I should also create more space. Delete. The last problem, 4.4, what is the value of the first term of the pattern to be greater than what? To be greater than 9,800, right? Yeah. So if I were to solve this problem, I was just gonna do this. right, and say I have what? I'm gonna go back to the original and say n squared minus 2n. Then of course now transposing 2n, and then here it's gonna be what? It's gonna be minus 9,800. Right? Yeah, so to be very fast, I'll use the quadratic formula. I'll say n is equals to minus b plus or minus square root of b squared minus 4ac over what? Over n, no, over 2a. 2a. That means I have 2 plus or minus square root of, this is gonna be 4, minus 4 into what? 1, and minus 9, 8. Right. And 2 into 1. I just put the whole thing in a calculator. 2. I'll go with the plus for the first time. I have 4 minus 4 times 1 times, I'm gonna make it positive. Actually, I should make it negative. Yeah, and I'm getting what? I'm getting 100. Right? I'm getting 100. Let me now put a minus. And I'm getting minus 90. Yeah. So now remember, term numbers are positive, ne? Yeah, we don't have a negative, term number. Right, so of course we're not going to use this value. The value of interest is going to be this one. So in that case, since I'm getting exactly 100, it's not a comma something, ne? I'm going to try to substitute that value. Right, I'm going to say n squared, which is 100 squared, ne? Minus 2 times 100. And look at me, ne? If I substitute 100, if I say t 100, which is equals to 100 squared minus 2 into 100, I'm getting what? 9,800. So here, I think they made it just easy, because you're getting exactly that value. So they made it very easy. They say, what is the first value of the term? The first term of the pattern to be greater than that. I mean, it's very easy here. It's very easy. You are seeing that term 100 gives you exactly that. Therefore, the term is term. It's gonna be term 101, right? Because of course now you put n1, you put 1, you're getting a value greater than 9,800. So that's the first one. So if the question is now, like, what if the value that they did put here, say let me make it what? Let me make it 750. 750, ne? So I'll go here. No, I need to raise. Yeah. So 750. That means here it was gonna be 750. And I go back again. I'm like, I have 2 plus square root of 4 minus 4 times 1 times minus 9750 and 2. Now look at me. I'm getting what? Here in that case, let me use the, yeah, if this was the case, I'm getting 9.7 for 7 blah 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 blah, ne? And if I do the minus, it's a negative value. I don't care about it. Now if I go to my equation, ne? And I'm like 99 squared minus Yeah. uh Minus that, ne? I'm getting a number below 9,750, ne? But now you look at this comma thing, ne? You realize that the next value after that, if you just round up, which is 100, it's gonna be greater than 9,750. So we go here with like 100, we go there with like 100, you get 9,800, which is the first, which is the greatest value after this one in our terms. So that's how you do this one. That's how you do this one. Yeah. So this is the last problem. I'm looking. Yeah, this is the first time. It's the first time making a video so long. Um. So I need to put this one way up. Okay, not to waste any time. I'm seeing the video is already long. Let me finish this one. Determine the biggest numerical term here, right? The numerical value of for term n. So here we remember there was a question that was say determine the what will be the smallest number in the equation. This one it's saying what will be the what the biggest number. And the reason it's saying the biggest number, you look at your a is negative, your a is below 0. And what does that mean? It means that in your parabola, drawing a parabola, you're going to have a parabola that is frowning, and then we'll have a value here which will be the biggest value, because any other values of tn, they'll be decreasing. Yeah, bo. So from this point, let me call this point B. From B going downwards, your values will be decreasing, implying that B will be the highest value or the biggest numerical value for Tn in our case. So since we did a problem like that, I'm just going to say go back to the video, look at the formula we used, and use exactly that formula. You're going to get the value. Maybe just for spoilers, I think the formulas is minus B squared, then it's minus 4ac, and then what do I have here? And then this is no, it's 4a, right? Let me check. Let's check. Let's check this thing together. Yeah, I'm right. So that is the formula you're going to use. You're just gonna take this formula, substitute it, and then bam, you're done. Good luck, guys. Thank you so much for your support, and yeah, see you in the next video. Oh, in the next chapter, by the way, because this is the end of this chapter. So see you in the next chapter.